Hello, welcome back to LIVENODING. This episode, I want to talk about populate mesh nodes in SVerchok. It's kind of like the hard way to randomize points on mesh and then create instances, but I just want to talk about it anyway. The SVerchok documentation is actually quite nice because it gives you some examples that's usually Geometry Nodes doesn't. So populate mesh basically give you ability to randomize points on mesh. Okay, it's very similar to Geometry Nodes version. Let me show you example. So we can start with a cube, or we can make our own starting point, for example the icosphere, and we can distribute points on faces or inside the volume. We can use this one. So this one will distribute points on faces, and if you increase the number, you sort of see random points on the faces. It doesn't give you ability to specifically say how many points on the surface, but the SVerchok one actually kind of does. So the advantage of Geometry Nodes version is that you can just simply instance on points, and we can use for example something like curve line and then use it as instance. So the advantage here is that we can just use the normal rotations and plug it into the instance on points, and we get results. It's something that's similar to hair. Okay, so this is distribute points, and I want to show the same thing using SVerchok. For now, I'll just hide this Geometry Nodes one. So it's like manually instancing random points and then replace it with lines. Okay, let's make SVerchok version. So icosphere, mesh viewer. So we have icosphere, and let's create random points on mesh, populate mesh. So let's, to plug this together, select both and then type V. Okay, vertices faces goes in. So we're gonna have vertices. Here we can specify the number of points. So similar to Geometry Nodes, we actually have surface, volume, and edges. Edges one is actually pretty cool. You probably need to plug in edges. So this is something that you can do with Geometry Nodes, but just SVerchok's slightly different. So let's just use surface, back to surface. There's these options to use the face weight, seed. Anyhow, that you cannot right click and show online manual. In this case, you just Google search for populate mesh, and it's gonna take you to this page. So yeah, distribute points, and we want to be able to use the normal, and in this case we don't have normal output from here, but there's actually some normals that can be calculated using origins. So we can calculate the origin normal. It's gonna calculate the normal, look at the vertices, edges, and faces. In this case we want faces, and we want to be able to use the normal, right? So matrix normal, I believe you can actually simply use the matrix. Oh, actually the normal. If you try using the location and the normal, and then use the matrix right away, it's not gonna work. Because we actually need to do something here. I think that the number of vertices coming from here will not match the one that's specified by the origin here unless we use this face index. So I know this because there's this example over here. Normals of faces of regular solid located on random points. Yeah, so we have our original primitives, populate the face, populate the mesh using its points on the surface, and we can take the origins, take the normal data using list item. Okay, so that's what we need to do. List item. It seems to be slightly more complicated, but if you learn a little bit more of SVerchok, you will understand geometry nodes fields actually work. Fields is a slightly complicated, a little bit more complicated concepts. It's like if you imagine fields, you know, like points in 3D space or points on the surface, and how you can, you know, use the points and influence the points, and how you can pass attributes, those sort of things. For now, don't worry, we're just gonna use this normal and pass this item to the normal here, and pretty soon we will see we're gonna get something that we want. Okay, there you go, like points with the normal that's facing out. And we actually have 500 objects being generated over here, coming out from SVerchok. We can actually merge it into one. So I'm scrolling just to get the right normal. Yeah, I think we get the result here. Maybe the normal is flip. So we need to flip. Flip the normals. I think, okay, let's actually turn off the center. Turn off face orientations. Okay, I think we get it. Don't worry about flip normal. I think you can try to reverse the normal yourself, but okay, this is populating the mesh points on surface. Okay, and this is using SVerchok, kind of the hard way, but you see this is also, there's also like fields going on underneath, you know, like fields calculations, but the way SVerchok do it is it's referencing the face index of each normal on the surface, and, you know, somewhat pass it into the matrix normal so we can use it to instance the objects. All right, so if we want to do it using geometry nodes, that's a little bit more complex, but actually easier. You can also use the asset browser. We have something similar because this is something that looks like hair. we can actually we can take advantage of this ourselves. So okay, let's try with a cube, and back to geometry nodes. We want the icosphere for now, just simple icosphere, and back to assets browser. We can generate hair curve, right? Simply drag and drop. So we have curve, hair, control the length. There's a lot of control here, including control points, density. Can we randomize the hair length? Maybe we can. Don't worry about that for now. Just maybe use one of these. Freeze hair curve. Just drag and drop it. So our curve can be shaped. Oh, okay. We have frizzy hair. Can control the hair length, control points. So pretty handy. The beginning and the end is kind of sticking there, but I think this is part of the feature of the freeze hair curve. We cannot dynamically control this yet. I don't think so, but yeah, we got the setup. If you go back to geometry nodes and take a look at the nodes, it's starting to get a little bit scary, but if you actually rebuild this yourself from scratch, this might make more sense. Interpolate curve. You definitely need to dig inside of this. Distribute points on the face. Yeah, there's a lot of things going on. Cannot explain all, but anyhow, we have multiple different ways to generate something similar using SVerchok or manually using. Just the simplest one is using distribute points on the face. This one is using hair. If you want to render this out, just add another geometry nodes and curve to mesh. Oh, we're gonna get rid of the original objects. In this case, we can actually separate the geometry beforehand, but I will just show it to you how we can render this as a mesh like that. Reduce the control points or have more. There must be a way to control the length from the asset browser. Attach hair curve. There's trim hair curve. This might be trim hair curve. This, if we drag and drop it, put it before. So length factor, we can definitely randomize and offset it there. Randomize the seed. Okay, so if we don't want the icosphere, we can use anything like Suzanne. Drag and drop Suzanne. It's the geometry, and we should have our hair on top of Suzanne. So there you go. It's a yeah. So there are three different things going on. First one, using SVerchok, which is this one over here, seems to be more complex, but if you dig through and then take a look at the example, you're gonna get something like understanding of field a little bit better, and how the data get transferred, or yeah, the data gets processed and get transferred from one to the next. The geometry nodes kind of doing the same thing, just slightly, sometimes a little bit longer and complicated, but it's still the same thing. Surface geometry, the domain mesh, what is this? It's kind of going. At some point, maybe we should make a video, just rebuild this and try to understand what's going on. Curve, interpolate curve, capture attribute store, join the geometry from the original. Oh well. Even the trim one is slightly complicated, but sometimes you don't need to understand all. You just need to control it from the parameters, and it should work. Should be okay. There's also this mask texture that we didn't use. But anyhow, I think geometry nodes functions is really shown. It's gonna be like clearer if you are actually using it, maybe with simulations like hair, particles simulations. So yeah, maybe in the next video I should talk more about hair somehow. So thanks again for tuning in. Hopefully this one's useful for you. And I'll see you next time. Thank you. Bye.